By meteorological standards, the natural La Niña cycle we experienced should have acted as a global air conditioner, keeping temperatures relatively cool. Instead, the heat trapped by greenhouse gases overpowered that cycle, and the 3-year global average has officially crossed the 1.5 degrees Celsius warming threshold. This global heat map shows how 2025 temperatures actually ranked compared to the past 30 years. The continued burning of fossil fuels has driven human-induced warming to 1.3 degrees Celsius, creating exceptionally high, record-breaking heat across nearly every major landmass. However, a uniform rise in the Earth's average temperature doesn't mean the consequences are distributed evenly. The reality of a hotter planet is highly fractured. Who bears the brunt of these extremes depends heavily on where you live, how you make a living, and whether scientists even have the instruments to track the danger. Take the extreme heat wave that struck South Sudan in February 2025. Heat is notoriously difficult to track because it doesn't leave physical wreckage behind, making it a highly effective silent killer. This bar chart comparing 7-day extreme heat intensities shows exactly how much of an impact human activity had on the event. The burning of coal, oil, and gas made the region 4 degrees Celsius hotter than it would have been in a pre-industrial climate. And these dot grid diagrams map the alarming shift in frequency. What used to be a 1 in 1,600-year anomaly for South Sudan is now expected to happen every other year. The burden of this extreme heat is heavily gendered. In South Sudan, 95% of employed women work in the informal sector. Because their jobs are concentrated in agriculture and street vending, they spend their days engaged in hard physical labor with zero protection from lethal temperatures. The fallout cascades from there. When the heat forced a 2-week nationwide closure of schools, it disrupted daily life, increased the likelihood of permanent learning losses, and made it significantly harder for young girls to ever return to the classroom. A heat wave does not affect a population equally. It targets and deepens pre-existing social vulnerabilities. Meanwhile, in the global north, extreme weather interacts with highly developed infrastructure. In January, a delayed wet season and intense Santa Ana winds fueled massive wildfires in Los Angeles. Scientists were able to calculate that climate change increased the likelihood of that specific fire weather by 35%. And because of the region's wealth, the damages could be carefully quantified: $30 billion in insured losses. Compare that data-rich, highly insured disaster to the heavy rainfall events in Botswana and the Democratic Republic of Congo. In fast-growing cities like Kinshasa and Gaborone, rapid urbanization and deforestation have stripped away the landscape's natural ability to absorb water. When heavy rains hit, drainage systems are completely overwhelmed by the population density, resulting in deadly urban flooding. The physics of a warming atmosphere trigger the heavy rain, but the resources and built infrastructure of a region determine who survives it. When researchers at World Weather Attribution tried to analyze recent extreme weather in places like Argentina, Venezuela, and Kinshasa, they ran into a wall. They simply could not draw confident conclusions about the role of climate change. This map displays the 2025 extreme weather studies. The Global South lacks the basic weather stations covering the Global North. Furthermore, state-of-the-art climate models were primarily developed for the Global North and often failed to accurately model the complex weather systems in the Global South. The scientific foundation is uneven. We are trying to warn half the globe about a deadly atmospheric threat, but we don't have the scientific instruments in place to measure it. This raises a critical question. What happens when a highly vulnerable region actually possesses the data and the forecasts to prepare? During the 2025 Atlantic season, Hurricane Melissa approached the Caribbean. Both Jamaica and Cuba had steadily improving forecasts a full week ahead of landfall. Authorities executed a textbook disaster response. They pre-positioned supplies, opened hundreds of emergency shelters, and successfully evacuated over 700,000 people from low-lying areas in Cuba alone. Despite that near-perfect advance warning, the storm's intense wind and rain still resulted in catastrophic physical damage. Homes were destroyed, and coastal infrastructure was severely damaged. Early warning systems and mass evacuations save lives, but adaptation has a hard ceiling. Human engineering and logistics cannot indefinitely withstand the sheer atmospheric physics of increasingly violent storms. Because preparedness can only absorb so much damage, and because the global impacts are so heavily skewed against the vulnerable, every fraction of a degree of warming matters. The only way to prevent unlivable extremes is to rapidly transition away from fossil fuels.